Hello everybody, this is Mr. Kinney. We're going to go over, this is a little addendum to our notes, in case you were gone or just needed a refresher, how to find an empirical formula. Now, the first part of the notes, we went over this, we talked about, for example, if you have a compound that is C2OH4, I think this compound's name would be ethene, but the empirical formula for this, we need to we need to reduce these to the lowest number there. So if you can divide both of those, the lowest common multiple there is 2. So that would make the empirical formula for ethane is going to end up being CH2, because this rounds off to 1. We really never put the 1 there, and then that'll round down to 2. So CH2 would be the empirical formula for this. I also reminded that glucose sugar, C6H12O6. Okay, so if you had that, its empirical formula is going to be, now the empirical formula is that when the chemists first started working with figuring out how much carbon and hydrogen were in a compound, they didn't know the concept of the mole. They didn't know a glucose sugar had 6 carbons, 12 hydrogens, and 6 oxygens, but they did know, okay, 6 is the lowest common denominator, they did know that there was, for every 1 carbon, there was 2 hydrogens, and for every 2 hydrogens, there was 1 oxygen. So they found out the ratio. So the empirical formula for glucose is CH2O. So that would be the empirical formula. So chemists, a lot of times, they can find this ratio, and then using the concept of the mole later on, they can go in and find what's called the molecular formula. But here's the steps. Now, this is in the notes. I'm just going to give this in class, but in case you were gone. So we're going to try to find, let me zoom out now, we're going to try to find the empirical formula. Let's say we've done an experiment, a colleague has, and they said there's 74% oxygen in this compound, 25.9% nitrogen. Okay, now this is an example from the book, but I'm just taking you through it. So the first step, assume you have 100 grams of this compound. Because it's real easy to change 100 grams if you know what the percentage is. So what is 74.1% of 100 grams? You got it. So step number 2, we would find that we have 74.1 grams of oxygen and 25.9 grams of nitrogen. So that's that step. Now the next step, we need to convert this into moles. So to convert anything to moles, we want to, now, and I had a student ask me, in review for the stoichiometry, yeah, I'm not sure what to do to convert this into moles. Well, you're going to have to start with your given. You've got 74.1 grams here, but now your conversion factor, now this is the divide sign, okay? You want to have the 16 grams down here in the denominator because you want that grams of oxygen to cancel with that grams of oxygen, and we know that's 1 mole. So it turns out, in this particular problem, you'll end up having 4.63 moles of oxygen. And then when you convert 25.9 grams of nitrogen, you need to divide it by the molar mass. 1 mole of nitrogen per 14 grams of nitrogen, you get 1.85. So at this point now, we know we have nitrogen and we have oxygen in this compound. We want to find out the ratios of those to get our empirical. Right now, yeah, so right now we're at, we don't know this, divide by the lowest number of moles, which in this case is 1.85 moles of nitrogen. So 4.63 moles of oxygen divided by 1.85, we end up with 2.5 moles of oxygen. And when we divide 1.85 by, we get 1 mole of nitrogen. So now that's going to make our empirical formula N1O2.5. Now hopefully you're hearing alarm signs going off, because from first semester, one of the laws of John Dalton was all compounds, molecules, are in whole number ratios. So we've got to convert this to a whole number, and the easiest way, we can multiply both things by 2. So that's the next step. We need whole numbers, so we need to multiply both of these by 2. So we can do it this way, or we can just multiply that. 2 times 2.5 moles ends up, we get 5 moles of oxygen and 2 moles of nitrogen. The empirical formula for this problem would end up being N2O5. So in the real world, maybe this compound is N4O10, but the empirical formula ends up being this. So there's how you do empirical formulas, and we've got your review sheets for you to get working on. So there. For my class, pardon me, we had, this is our practice worksheet problem, determining empirical formulas. We gave you the first part. Now the first part of this on that paper, the first part, you can get to this part right here, and then you have to do the second part. And so we said there were 75 grams of carbon that we divided by the molar mass of carbon. We got 6.25 moles of carbon. That would mean then for hydrogen, 25% hydrogen in this problem, because that's what it said. We had 25% hydrogen. We converted that into moles. The molar mass is 1 mole of hydrogen is 1 gram. We ended up with 25 moles of hydrogen. So now we got to divide by the lowest number of moles, 6.25. That's where this came through. And then 25 divided by 6.25 comes out to be 4. And so this compound would be CH4, or if you wanted to put a 1 there, you could. That's not really proper, but C1H4. And now we need you to get working on the rest of those. Good day.